Hello everyone, I'm forecaster Jack Sillin here to discuss the severe weather setup for the afternoon evening of Monday, May 28th here, Memorial Day, and we have a busy day potentially on tap here in terms of severe weather across parts of the high plains. We can see on GOES East water vapor satellite imagery a strong upper level low here across the Rockies, and as always we're going to look to the kind of front side of that for a combination of upward motion, moisture coming in from the Gulf of Mexico, and some dynamics associated with a surface trough kind of dry line feature in here. So this upper level low setting the stage favorably for severe weather. We have a couple of surface features I'll show you in a minute that will help to capitalize on that potential. Subtropical storm Alberto, quick note, moving ashore here in the panhandle of Florida. Could see a few tornadoes in the kind of northeastern quadrant of that system, but no major issues are expected as the system moves up to the north. This is going to be the primary area of intense thunderstorm activity. And you can see there's some already ongoing this morning. We can actually take a closer look at that here with a zoomed in version, our infrared satellite option here, and we can see thunderstorms already ongoing here from parts of northwestern Kansas through parts of central Nebraska. So these storms are already in progress this morning. If we press the HD button here, we can get a look at our HD radar. And actually some of these storms, is kind of the southern end of this line, are severe warned for large hail and gusty winds. So keep an eye on these storms over the next few hours. They're likely going to continue. We could see a little bit of a drop-off in activity around midday before the main event gets going later on this afternoon. In terms of this system's impact on the rest of the day, we could see later severe storms slightly weaker in this area where there might be less instability. If we go back to our wider view and then our GOES satellite imagery, we can see that again there's plenty of cloudiness here. Again, this is starting to get into the visible satellite imagery, so we can select our visible satellite imagery here, and you see this cloudiness that'll help to reduce daytime heating, reduce surface instability compared to areas farther west and farther south where we have some clearer skies. So looking at our surface setup here, we have a dry line, well-defined dry line running through eastern New Mexico into parts of south central Colorado. This dry line is going to mix out to the east as it does when the sun comes up, so we'll see it set up from the panhandle of Texas through the panhandle of Oklahoma into parts of western Kansas. Right along the Kansas-Colorado border here, and extending up to the north into parts of Nebraska. There's a little bit of a lee trough here, a little area of lee low pressure that forms as southwesterly winds travel up and over the Rocky Mountains, then descend on the eastern side. You get an area of lower pressures, so that will also help to fuel severe thunderstorm or spark severe thunderstorm activity later today. Here's a look at our ECMWF's thunderstorm composite map. You can see plenty of instability here. No worries about that. This model may be overdoing it a little bit here again in areas near North Platte, Nebraska. That's where we're seeing that thunderstorm activity this morning. So depending on how quickly that is able to clear out, we could see some reduced instability in this area. But otherwise, parts of northeastern Colorado, plenty of instability, as well as farther south along the dry line. If we click near the edge of the map to pan south, you can see also plenty of instability here, Texas and Oklahoma panhandles. So we have our instability. The dry line that I discussed earlier, you can see that kind of subtle convergence, southeasterly winds to the east of the dry line, southwesterly winds to the west of the dry line. You get that area of convergence, and you'll get your severe thunderstorm activity to develop along that boundary. Wind profiles are veering with height and strengthening marginally down here in the panhandles of Texas and Oklahoma. Same general idea up here into Kansas and Nebraska. So that will support rotating updrafts, supercell thunderstorms. If we go over to this map, this is our bulk shear forecast, so deep layer wind shear, and you can see that the shear vector kind of pointed out as these barbs here, blowing out of the west towards the east, and that is perpendicular to our north-south oriented dryline boundary. So when you get a boundary perpendicular shear vector here, you're going to be looking for a more discrete storm mode, at least near the initiation. So as storms initially get going, you're going to watch for that discrete supercellular storm mode. Storms will be able to take advantage of that rotational energy in the atmosphere, and that will mean that hail will be a big threat today with those strong rotating updrafts, in addition to damaging winds. And then as storms kind of congeal into blobs or little linear structures later on in the day, we'll watch for damaging winds to take over as the primary threat. Tornadoes are possible, especially here in parts of Colorado. Kind of this area, we can see where our low-level rotational energy, low-level wind shear is maximized. So we have some of it here in Kansas, and then that will be strengthening as we move later into the afternoon and evening. But anywhere in this area here, and this is likely a little bit underdone in parts of Colorado, so there are some localized terrain features here near Colorado Springs that will help to again create some of that low-level rotational energy you need for tornadoes. But tornadoes is likely not the primary threat today. That will be large hail transitioning towards damaging winds. Speaking of large hail, I want to explain a little bit of the science behind why that's such a big threat today. And this is the moisture at 500 millibars, so about 25,000 feet. And you can see very dry air in the mid to upper levels here. Now, why is that important? Well, as air rises in the updraft of a thunderstorm, it's moist air that you're taking from the surface. That's why you need that moisture east of the dry line. So that moist air is rising up through the atmosphere, and it's condensing as it does so. And then when it runs into this dry air, it also starts evaporating. So you get an evaporational influence there as well. Now, why is that important? Well, as air evaporates, or as water droplets in the cloud evaporate in this dry air, the phase change, the process of that water going from a liquid or even a solid phase once you get up to the 500 millibar level to a gaseous phase. So that's the evaporation. So when you go from a solid or a liquid, lower energy states of the molecules to a higher energy gaseous state, that transition requires energy. Now, where does that energy come from? Well, it comes from the surrounding air. So the air surrounding those water droplets, and when that air is deprived of some of its energy, it cools. So you're going to get this cooling air in the thunderstorm's updraft, and that's going to help to freeze even more of those molecules, which again is going to drive even more cooling. So what you're going to get is this kind of compound process here, the evaporation, the freezing, both driving down temperatures in the mid to upper levels of the thunderstorms, and that's going to be especially conducive for hail development, in addition to damaging winds, because when that air cools off, it gets denser, heavier, and is more prone to sink down towards the surface. And when it sinks down towards the surface, it hits the surface and spreads out. That's when you get your damaging winds along the outflow of the thunderstorm. So a little bit of the science behind why we're looking for a hail threat today. It's this dry air in the mid to upper levels that is also helping to fuel a damaging wind threat. So here's a look at the simulated radar map. As always, don't use this as a precision tool for exactly where thunderstorms will develop. Use it more as a general guide to how a setup might evolve over time. So fairly quiet. We're looking for some of that lingering shower and thunderstorm activity here in Nebraska early this afternoon. And then as we move later into this afternoon, so this is 5 o'clock Eastern, 4 o'clock Central Time, you're going to see those storms develop along the dry line, develop closer to that lee low here in parts of northeastern Colorado. And then as the evening goes on, you're going to watch for those initially discrete cells to congeal into linear structures here, while that discrete storm mode may be maintained a little bit longer in northeast Colorado. So plenty of intense storm activity expected here across parts of the high plains. Large hail, primary threat, transitioning towards damaging winds as the afternoon and evening goes on. Tornadoes can't be ruled out, especially in the southern part of this risk area. That's it from me for now. You can follow along with the storms all day today with the tools we have at WEATHER.US. I've showed you some of them here. We have our GOES East satellite imagery, we have our HD radar imagery, we have our lightning analysis tool, so you can see exactly where lightning is striking. Click the map to zoom in, and once you zoom all the way into zoom level 4 here, you can click any one of these strikes for much more information. So plenty of tools to help you stay ahead of the storms today as they develop. Watch for those later on this afternoon and evening. That's it from me for now. Thanks for watching.